Hello and welcome to a quick chat about spaghetti code in the open source. I know the title is a little bit different, but essentially it's going to be a lot about untangling spaghetti. I have good news and bad news. The bad news, this talk is not going to be nearly as good and professional as the previous one. Good news is I'm going to make it shorter. You don't have to suffer that long. My name is Jan. I'm a software engineer at Kedify. We are a small, tiny startup, 5 people, and we help other companies to fix their auto-scaling issues and scaling issues. If you have any scaling issues, feel free to reach out. Also, if you don't have any scaling issues, we're good also helping you find them. Let's start with a quick exercise. This logo on the bottom corner, who knows what it is? All right, you win.
No, I'm kidding.
Excellent. I like both answers. So another exercise, who wishes this was never introduced to the world? All right, a couple of people. I'll disappoint you further. There's going to be a little bit about this. This is Kubernetes, cloud orchestrator. You run your apps on top of it. Who knows this second logo? Nice. That's more than I expected. This is KEDA. It's a little extension of Kubernetes. It helps you to auto-scale your applications. The long version, Kubernetes Event-Driven Autoscaling. What it does, you deploy your application. It can help you scale it to multiple replicas, scale back. Also, it can help you completely pause your application and bring it back on. During the time when the application is scaled down to 0, it can also help you cache the requests and then replay those requests to your app. What's good about KEDA is these bunch of logos. Like, you can do auto-scaling with many different technologies. KEDA picked an area where it tries to integrate with anything, including Datadog. These implementations, these integrations, they are called scalars. And various people from various companies contribute how these scalars get configured. The first commit in KEDA, oh, by the way, KEDA is an open source software written in Go. The first commit was 2019. Since then, there have been a lot of contributors. KEDA has been evolving for quite some time. In the last 6 months, there were 104 forks and 700 stars. So that's roughly 10% of social connections and network happening just this year. And Jorge, this guy that I took a screenshot of, he is a long-term maintainer of KEDA, and he also witnessed how a lot of companies contributed, a lot of people contributed, and he, to put it mildly, wasn't very happy with the overall quality of the code. And I am going to show you a little bit more about it, some internals. So KEDA source code, this will be structure, we'll untangle it together. How usually every single scalar, every single integration with external software, with Elasticsearch, Datadog, Google, AWS, you name it, how they need to configure. There's other fields, but the main fields are three maps, and they're always string to string. If you want anything else than a string, sorry, you have to pass a string, unfortunately. It doesn't matter what type of value do you expect. So this is kind of an example that we're untangled. It's a hypothetical scalar, hypothetical integration to external software. Because usually the scalars, they have like 20, 30 entries and they wouldn't fit well. So I made up something that loosely resembles them. So you would configure your endpoint, some form of a threshold, when it's supposed to scale up, scale down, some bounds, for example, to limit the values that are supported, and also how to authenticate, right? So if you have your Elasticsearch, you need to authenticate with it. You're unlikely going to have the endpoint completely public for everyone to look at your metrics. And these strings, these 3 maps, they're not what you would easily pass to the client, right? Elasticsearch and Datadog and other scalars, they have their own structures that they expect with their own data types. So for the endpoint, string to string, that's easy. The threshold, the client may expect actually an integer. So you'll have to typecast or parse it and then cast it. Similar with ranges. And certificates are usually slice of byte. This is a clear Boolean, but you get strings. So how was the usual code implemented? And now we're getting to spaghetti. You have to tell in the implementation, like, hey, this is my map. This is the map where you're supposed to take it. This is the key. And you put the key into your concretely typed structure. And if you don't find it, throw an error. Not that bad, right? If it's just a single value for a single scalar. But if you repeat the same lines over and over again for 65 scalars, 20 plus values each, it gets worse also with types. You would have to parse the type. And also some of the values, they can come from any of the three maps. And you would have to define a behavior which one has a precedence over the other. So obviously, Jorge was pretty unhappy about the situation, about the repetition, about the number of lines that it was taking just to do silly parsing of the configs. There were a couple of iterations. Some people tried using generics. Some people tried using reflections. And ultimately, we settled on the reflections-based. The API that we were targeting and we enjoyed to work with and thought was fairly similar is the JSON marshalling, right? With the JSON marshalling, you control the behavior nicely with the field tags, and we introduced very similar field tags to your concrete data types. You would start with the definition of the name. What's your key to access the structures, the maps? And also, there are three maps, so you can control the order. Like, not everything has to go from the trigger metadata. It could be the out params or the resolved env. Here also, with this approach, reflection-based, going over the field tags, you have a benefit of knowing the actual data type. So you can write it once. You can say, oh, by the way, this is going to be an integer. There's one piece of logic, one piece of software, one location, where for all of the integers, it will go through every time. Similar for all the other values. And yeah, this is kind of a shorter version, but you could also define the order with more than a single map, but also all three of them, and they will be accessed in that particular order. How does that work? Now, the entire code, it actually wouldn't fit here, but the gist of it is based on the reflections. There are very few functions from the reflection package that we needed, and we found out that it's surprisingly easy and pleasant to use. There is a function that will give you the type and all the details about the type, so you can iterate over it. There's also a reflection function that will help you to store the value, right? So you have the concrete type, you have the concrete structure, and you want to insert the value that you found in one of those maps. So there's this, and the value itself can be any arbitrary number. You control if it's an integer, you control if it's a string. There's also a way how to iterate over all those fields. So when I show you this iteration, this is how the algorithm works. It iterates over one by one and figures out which map to take the value from and insert it. And the last but not least, look up the field tags, the little green part that you see on this screen. That's a reflections helper to give you that entry. Now, how far we've gone? We started with this approach in April. In April 15th, the PR has merged. Since then, the community started working. It took a little bit of time to educate people what's the new approach. 7 of the original 65 scalars have been done. 2 are currently under review, and people are starting to promise to refactor more and more of the code. There's been some code additions, mainly the parser. That's majority of those 620 new lines, but majority of it is just deleting the spaghetti, which was what we actually wanted from the very beginning. And as I promised, it is going to be a lot shorter, so you don't have to suffer that long. This is my conclusion and last slide. Thank you very much.
How do you test that the refactoring is over?
So there's extensive unit test and E2E test framework part of KEDA. And yeah, that was like one of the major factors. With any refactoring, with any changes, we couldn't break anybody. That was the most important thing. Like deleting code, pleasant, breaking somebody really bad. So we just run the unit test. In order to merge a PR to KEDA, you Jorge is pretty pedantic about it. You have to provide extensive unit test coverage and ideally a couple of end-to-end tests. Otherwise, no matter how good the PR is, he's not going to merge it. Yes.
How do you decide which field to put into the type? Like, I'm sure some people decided that set will be something else or so.
So this is driven by the scalar themselves, so the integration itself. So if you integrate with Elasticsearch, I'm picking on the technology because my mind is drawing blank on other terminology. So if you want to integrate with Elasticsearch, they usually have a Go client. Now, Jorge and Zbigniew and the other maintainers, they are going to ensure that you don't merge or propose a code that's like completely ridiculous. So they will take a look at, oh, what's typical clients for Elasticsearch? Oh, this one is like the most popular on GitHub. All right, let's try to navigate the contribution to use that client. And the client, it usually takes some form of a structure, some form of data types. So that's what drives what types are supposed to be there. Make sense? Kind of.
There is more to it.
More questions?
You have said that you have chose reflection over genetics. Why? As far as I know, reflection have some overhead, runtime overhead.
Yes. Yes, reflections have overhead. Luckily, the overhead is dominated by rest of KEDA. So you construct this once for every scalar, and you obtain the values from network, from Kubernetes API. So that is by orders of magnitude slower than any reflections. So it's not the major issue for us. And with reflections, it was very easy to implement with the field tags, the green part of what you see on the screen. So major reasons were convenience, ease of use, and I guess we also wanted to learn something. We didn't use reflections before. We thought, how does Go do the JSON part marshalling? Like that's what we want. That's a user interface and interaction that we would like to have. And by user, I mean developers or contributors to KEDA.